scientists have gained the best view of the brightest explosions in the universe. An observatory in Namibia has recorded the brightest and most energetic events known to occur in the universe. So, what are these exactly? Well, these are called gamma-ray bursts, GRBs, which are immensely energetic explosions that have been observed in distant galaxies. These are considered as the birth cries of black holes. These bursts were first detected in 1967 by the Vela satellites. Gamma-ray bursts can last from 10 milliseconds to several hours. After an initial flash of gamma rays, a longer-lived afterglow is usually emitted at longer wavelengths. These intense radiation is thought to be released during a supernova as a high-mass star implodes to form a neutron star or a black hole. The sources of most GRBs are billions of light-years away from Earth, which implies that the explosions are both extremely energetic and rare. A typical burst releases as much energy in a few seconds as the Sun will in its entire 10 billion-year lifetime. All observed GRBs have originated from outside the Milky Way galaxy. Although a related class of phenomena, soft gamma repeater flares, are associated with magnetars within the Milky Way. It has been hypothesized that if a gamma-ray burst in the Milky Way points directly towards the Earth, it could cause a mass extinction event. On August 29, 2019, the satellites Fermi and Swift detected a gamma-ray burst in the constellation of Eridanus. The event, catalogued as GRB 190829 according to its date of occurrence, turned out to be one of their nearest gamma-ray bursts observed so far, with a distance of about 1 billion light-years. GRB 190829 is only the fourth gamma-ray burst detected from the ground. The afterglow was detected up to 3 days after the initial explosion. The short distance of this burst allowed detailed measurements of the afterglow's spectrum, which was up to an energy of 3.3 teraelectronvolts. That is, about 1 trillion times as energetic as the photons of visible light. This is something exceptional about this gamma-ray burst. However, the earlier detected explosions occurred much farther away in the cosmos and their afterglow could only be observed for a few hours each and not to energies above 1 teraelectronvolts. The reports were even more surprising as the observations revealed curious similarities between the X-ray and very high-energy gamma-ray emission of the burst's afterglow. Established theories assume that the two emission components must be produced by separate mechanisms. But the observations of GRB 190829's afterglow now show that both components, X-ray and gamma-ray, faded in sync. Also, the gamma-ray spectrum clearly matched an extrapolation of the X-ray spectrum. Together, these results are a strong indication that X-rays and very high-energy gamma-rays in this afterglow were produced by the same mechanism. The far-reaching implication of this possibility highlights the need for further studies of very high-energy GRB afterglow emission. So, let us know what you think on this. Also, subscribe to our channel.